Well, today what we're going to talk about is what can the free SOLIDWORKS CAM that comes with SOLIDWORKS do for you? What do you actually get with that? Is it just some scaled down thing with limited power and really no application, or is it an actual product that you could use and you could integrate into your shop environment? And I think I wouldn't be doing the webinar today if I didn't think there was real power in it. What's going to be interesting is kind of the history and the background of that product. So for years, we sold basically two versions of CamWorks. We had a 2.5 axis version, and we had a full 3 axis and above version. And then, lathe and mill turn were other options along the way. But in the beginning, we actually sold more of that 2.5 axis version of CamWorks than we did anything else in our company. Now, over time, as 3 axis grew, that became kind of the leading product for us. But back in the day, when CamWorks first came out, it was, mostly 2.5 axis cam, only in the part environment. And we sold, it sold for $5,750. And so what I think you're going to see today is that there's actually more capabilities in that free product than there were in the early versions of CamWorks at that price point. And I think you might be surprised with some of what you see in here as well. And along the way, we're also going to talk about some things like workflow ideas. And over the years with SOLIDWORKS, SOLIDWORKS CAM, and CamWorks, there has been a couple different competing philosophies on where you store your CAM data. And the nice thing is that with SOLIDWORKS, you've got full associativity no matter which path you take, but we'll talk about the different paths you could take. We're going to be working today on parts that come out of a thing called the Hot Rod Halo. And the Hot Rod Halo is a mobile show car barrier. And, this guy swivels around, swivels up and down, and this telescopic rod comes out. And then there's a spool of material that threads out through this end. And you string 4 of these things. You run your tire over the surface right here. So you put 4 of them underneath your tires. Angle this guy out towards the corner of your car, pull the string out, hook 4 of them together, and you've got yourself a show car barrier that will fit in your trunk. And we're working with the manufacturer. They're great guys, and we've really leveraged the power of SOLIDWORKS to optimize the design and to optimize the machining and to design great fixturing around that as well. And so we'll be focusing today on this part right here in the part environment, but we're actually running these, both halves of this part right now on one of our mills. Before we get started on that, let me give you a little background on CAMs. We've been in business for 28 years. We've been focused highly on manufacturing during that time. And today on the phone with us, we've got Brian Suchland, who's our Director of Software Services. Do you want to say hello, Brian?
Yeah, hello guys. Thank you, Jeff, for taking the time to introduce me. But yeah, I've been with CAMs for 16 years now, Jeff, with support using CamWorks and SOLIDWORKS CAM. So it's been a fun, long ride, and definitely enjoy the product. So I'll let you back at it, Jeff.
Thank you, Brian. And so one of the things that's an absolute blessing about Brian is that he's one of the top, maybe 2 post writers in the country, and certainly top 4 or 5 in the world. So we like to say the difference between a pretty picture on the screen and the correct code might be a crashed machine. And so Brian creates wonderful post processors, and he knows the product frontwards, backwards, and sideways. And he's here just to keep me on track in case I share anything that's wrong. And then we've also got Don Hope, and Don is our Director of Business Development. Don, would you like to say hello?
Good afternoon, everybody. I'm glad to be here today. I'm looking forward to the presentation with the SOLIDWORKS CAM, just one of the components that's included in the SOLIDWORKS ecosystem that SOLIDWORKS has developed and continues to add to. Other products that we include is the PDM, the simulation, the electrical, documentation. So there's a lot of things involved in SOLIDWORKS right now, and today we're going to focus on the SOLIDWORKS CAM and the basic, the 2.5 axis milling. But I'm sure Jeff will point out eventually that the it also integrates well with CamWorks. It goes up to five axis that we can do. So I'll let Jeff go ahead with there. But if you have any questions, just give me a call. Thanks.
Hey, thank you,
I'll chime in here for the guys in the meeting. If you guys have any questions, feel free to ask. We can see them in the chat. There should be a little button in the bottom where you guys can ask a question, and I'll do my best to answer. If not, we'll talk about it near the end of the webinar before we sign off. So go ahead, Jeff.
All right. Thank you, Brian. I appreciate it. Yeah, so we've been, as I said, we've been doing this a long time, 28 years in business. Over the last few years, we've really grown the business. And today, who is CAMS? We are, number one, we think a SOLIDWORKS reseller. SOLIDWORKS is a great supplier, and we're, very, very proud to have that product line. And we feel it provides amazing value to the marketplace. We've been a CamWorks reseller since the product came out in 1997. Worked with them before that, even on the direction of the product. And we're also a Markforged reseller and big rep reseller, so we do some 3D printing. And then we have a full machine shop as well. Not a big machine shop, small machine shop, about 4 machines back there right now, plus a 5-axis CMM. But we've got 3 through 5-axis milling, 8-axis mill turn, and some other machines as well. And the reason we have those is so that we can be better at actually the mechanics of this whole process, and that we can help our customers at a higher level than someone who's only doing it theoretically. I tell people I never broke a tool in the CAM system in 26 years, but when you get out and start making real parts, you might break a tool, and I have. So anyway, let's look at how we would machine that, and let's look at the capabilities of SOLIDWORKS CAM Standard. And so if we wanted to work on this part, we could go ahead and open that part up. And we'd immediately have 2 choices. We could save the CAM data right with our original CAD model, or we could choose to insert this part into another part, and then we could just have a very specific manufacturing model. And that's what I like to do because, it still maintains that one-way, in that case, associativity without taking the chance of putting sketches or something in my original CAD model that might make it less presentable if I'm using it in, say, like a sales or presentation or engineering environment. So I'd simply go up here and say File New, and we'll create a new part. And here we've got a part, with all our standard defaults and things like that. We'd go to the Insert command, and we'd insert a part. And immediately it knows that I want to insert this part, and I've got some choices over here. And I could choose a different part to insert if I wanted. But I can insert the solid body, I could insert surface bodies, any axes, I could bring planes along if I wanted them. In this case, I don't. I'll just use the planes that are already there. I can bring cosmetic threads, absorbed sketches, unabsorbed sketches, custom properties, coordinate systems if I've already defined those, model dimensions, and whole wizard data, and the material as well. And in this case, I'm not really too concerned about bringing that material, so I'll turn that off as well. And when I hit the check, it goes ahead and it asks me, hey, do you want to switch to the units that were used originally in the design, or do you want to use the defaults that are in my part file? I'm going to go ahead and change it and switch to the units that I always design with. And so here we've got this part. Again, we've got the one-way associativity back to the model. So if we change the model, then this part will update. But anything we do in this environment is not going to clutter up our CAD model. And so this is a workflow that I like a lot. And for us, we might go ahead and we might say that we want to save as, and we'll go in and we'll put it in our Hot Rod Halo machine shop directory. And we could call this the hub with spooler. And that's the little interlocks on the side. And we could say dash cam MFG or something like that. And so we'll save that guy off. And then we're going to go over, and we've already got our cam icons up here ready to go. And we're going to go over and then just define our cam data. So let's go in and we'll pick our machine. And we'll take our 3-axis machine. Let's go over and grab our tool crib, and we're going to grab our Hot Rod Halo tool crib. let's go grab our post processor, and we're going to run this on our Herco machine, but we've got an Akuma machine back there. We've also got, you know, a mill turn machine back there, and so we could run it on any different one of these. So underneath our posting, Brian puts a lot of thought into his posts, and so we've got some choices here. He's one of the few guys that really has this high speed, you know, and every machine has its own high speed options. On the Herco, it's the G05P, and that allows us to specify, you know, what degree of look ahead we want, you know, what kind of accuracy, speed up, slow down, things like that we want as well. So he's actually manipulating the machine through that code beyond just the movements. And then sequence numbers, do we want line numbers, yes or no? We'll say we only want line numbers at our operations. Do we want to output a detailed tool list? We're going to say yes to that. Do we want to output comments? We'll say yes to the name and description of our comments and our operations. And then finally down here, we're going to say that we do not want to put an MOO if we're moving between setups. So we'll say no to that. Go over to the setup, and here we could define, you know, with CamWorks or SolidWorks CAM Standard, you're only going to get, you know, machining in one direction. So you're not going to have 4- and 5-axis indexing. That's going to be in the SolidWorks CAM Professional version. But so we'll go ahead and pick none for that, signifying 3 axes. Next, we're going to go ahead and we're going to define our stock. And as with every version of SolidWorks CAM Standard up through CamWorks Premium, you have a choice of defining your stock by a box bounding. It's kind of like a shrink wrap box of stock, or by an extruded sketch, and that could represent a laser cut part, water jet cut part, anything like that where you're kind of cutting out a basic shape, but it's still got straight walls typically. You could have an STL model, and this could represent work in process. So we could be coming off the lathe or another mill or flipping the part over, anything like that could be STL model. It could also represent a casting or a forging. And then finally, you could represent the stock with another part file. And I do this all the time, but it's not required in this particular case. And then we could tell it, you know, how we want to, you know, how our stock is oriented or something like that. But we haven't chosen a coordinate system yet, so I'm just going to kind of go with this default view that you see on the screen. And I know that when I machine this part, I've got this guy facing up, and I've got, you know, these guys facing side to side. I'm holding it with some Mighty Bite clamps, and I'll show you an example of that a little bit later. And so, so the first thing I'm going to do is I'm going to say in this direction, which happens to be Z for the moment, and we'll change that in a minute. So don't worry about the Z, X, Y, Z direction. All we're doing right now is saying, in general, based on the reference I'm seeing on the screen, I want to add about 35,000 stock in both directions. And when we pick this little button, it creates a uniform, you know, creates that uniform 35,000 in both directions. And you can see that, well, here, maybe it should be 25. So updates that guy. Oh, and you know what? Actually, I bought this stock at 5 inches 50 thousandths, and so I was right the first time. So we'll leave it at 0.035. So that's how I bought the stock. Saw cut at 5 inches 50 thousandths in that direction, and then I touched it off, so I had about 25 on each side. Next, we're going to do this X direction, and we know that we've got about 10,000 stock in both of those directions. We'll make that uniform as well. And then finally, what's important in this particular case is we've got about 20,000 stock on the top of the part, and we've got about 130,000 stock on the bottom of the part that we're holding this with. So let's go ahead and we'll say OK to that. And now we're going to go ahead and we're going to define our coordinate system. So let's go in and edit the definition. And now we're going to finally say, hey, what direction is X, what direction is Y, and what direction is Z? We'll do this on a user-defined. If we had a SolidWorks coordinate system, we could pick that. We don't in this particular case. And we're going to say that our user-defined coordinate system is going to be relative. We could say to the part, but I actually want it to the stock, which is a little bit bigger. And then I can go in and I can pick any one of these nodes on the part. So I'm going to pick this node. I'm going to set my 0 point at the top, center of the stock. And now I'm going to go ahead and say, hey, my X direction is really going to be that direction right there. My Y direction is really going to be that direction right there. And it knows automatically that my default Z is going up. So let's say OK to that. And again, all this is absolutely no charge with your, if you're on subscription for your SOLIDWORKS software. So far, we've picked out our machine, we've defined our stock, and we've defined our coordinate system. And this is where SOLIDWORKS CAM and CAMWorks start to really leverage some of the power that's built into the system. In most systems, we'd go in and we'd start kind of choosing boundaries and tools and operations, and that's all fine. It's just that you'll be choosing them today, tomorrow, the next day, and forevermore, because they typically don't have any other options besides that. Now, we can work in that kind of a workflow, but we also have this ability to extract machinable features. And when we say extract machinable features, it's going to initialize a feature recognition engine. And we've actually got two feature recognition engines in the system. We've got AFR, automatic feature recognition, and we've got MFG view. And so, we could choose either one of those. And so we used MFG view in this particular case, and it came back and said, hey, we've got 3 setups. And so it thinks, hey, we've got to hit the material from this direction, and then we'd have to actually flip the part, hit the part from this direction, and those are both correct. And then it thought, hey, we're also going to want to do it in this direction, and it found some features over here. Now, in this particular case, we're not going to do this guy. And so we could either suppress or delete that. I'm just going to delete it to kind of clean up our view a little bit. And it goes in the recycle bin. We could restore it from the recycle bin or remove it. I'm just going to shrink that down so you don't have to see it. So if we went ahead and we said highlight recognized faces, it would show me everything that SOLIDWORKS CAM or CAMWorks thinks we need to machine. And that's all good, but we're just going to add a little more to it. So we're going to go back to this part setup. And, we've got a face feature. That's the first thing we're going to do. We've got a part perimeter feature, and that's something we're going to have to address as well. We've got a circular pocket in there. That's all good. We've got a hole group here. And I know that in this particular case, these are an 832 tapped hole. So I'm going to right click. I'm going to go to my parameters. I'm going to change that from a drilled hole to a threaded hole. And the system's pretty smart. And so it looks at that hole size and it tries to guess, well, what size might that be? Now, the only difference is that instead of cut tapping them, I'm doing a roll tap or a form tap. But we'd also have the choice of single point or multi-point thread milling. So I'm going to change that to a roll tap, go back into my library, find my 832, not 632, and say OK to that, and OK to that. And then we've got this countersunk hole feature, and that's just great. And for now, we'll just deal with this one particular setup. Let's go ahead, though, and let's add a multi-surface feature. And so when we go back and we talk about what was originally available in that CAMWorks 2.5 axis environment, well, it didn't have any of this. You had to go clear up to the $10,000 full-blown 3-axis machining environment to get any of this. And now, in that SOLIDWORKS CAM Standard, working on a single part, we can do some light 3-axis milling. And so we're going to go ahead and we're going to say, hey, select all the faces here. And so it finds every face on the part, and we'll contain it in just a little bit with a boundary. And let's go over here and what I like to do, so the next thing we're looking at, so we've already looked at feature recognition, then we're going to start talking about strategies or rules-based machining. And with rules-based machining, this is an ideal way for those of you who are skilled and been in the trade for a long time to share your knowledge with the people who are just coming up in the trade. And so one of the things we like to do is I'm personally kind of toying with this idea of, what's the best way to save off these strategies? And I know that in our shop, we've got 15 horsepower mills and we've got 30 horsepower mills. And so we all know that we're going to run those a little bit differently. And so for me, I've gone in here and I've made a 15 horsepower small multi-surface feature strategy. And if we look, it's going to come in here and it's going to do some roughing with a flat end mill and area clearance. It's going to do another area clearance with a ball nose tool. And then finally, it's going to do some finishing with a ball nose tool as well. So let's go ahead and we'll choose that strategy and we'll say OK to that. And I'd also like to change some of these other strategies. There's a nice tool for doing that. And we can go in here and pull up all the different feature types. And we can look at this circular pocket. And once again, we're going to run, this 15 horsepower volume mill strategy on that. We can go look at our open pocket. And, and actually, as I sit here and I think about it, I really shouldn't do this because volume mill is one of the things that you have to step up to that SOLIDWORKS CAM Professional to get. So maybe what we'll do is let's start out with the basic roughing and finishing, and then we'll come back and look at what would this look like if we went up to that SOLIDWORKS CAM Professional level. So we'll just do a rough finish here, and we'll do a rough finish here. But it's important to note, people cut parts for a long, long time, with all these basic routines. And so we'll say apply, we'll accept that, and let's go ahead and generate our operation plan. Now, when we look at this and we see these features in this magenta color, that lets me know immediately that I don't have any operations. And so we're going to look now, we're going to kind of move around these three tabs. This first tab is our CAMWORKS feature tree. The second tab is going to be our CAMWORKS operation tree. And this third tab is going to be, and again, when I say CAMWORKS and SOLIDWORKS, I use them interchangeably. So this would be our SOLIDWORKS CAM operation tree. And if we go over and we look, we've got no operations yet. We look at our tools, we've chosen no tools yet. And so we're going to go ahead and we're going to say generate operation plan. It's going to take these features out to a database, technology database. And it's real important to note again that, we've got a lot of people bought CAMWORKS over the years, and they're using it for all kinds of different things, but most all of them have SOLIDWORKS already. And so it's important to note that our customers can share these files, these SOLIDWORKS CAM Standard files with the CAMWORKS guys, and the CAMWORKS guys can share their files with the SOLIDWORKS CAM Standard guys. And the only thing that'll happen is if there are features or operations that are not supported in the CAM Standard, those will not be able to be manipulated or changed by the CAM Standard guys, but there's no reason they still can't work on the same files. And it's really nice that you can leverage that free version along with your paid versions as well. So once we do that, we can see that all these features turn black, and that's great. That lets me know that I have operations for everything. And then we can also see that the system has gone through and selected some tools. And we're going to start out and let's look and see what we've got for tools over here. We've got a 2-inch face mill, and I'm going to actually run this facing with that 2-inch face mill. So let's drag that guy up there. And at any time along the way, we can generate that tool path. So we can generate it from the tool tab. We can generate it from the operation tab. And then the system's going to come in and do some roughing. We're going to use a 1/2-inch end mill. And we could just go ahead and say, hey, just generate that basic 1/2-inch roughing operation here. And if we want to make some changes to that, we can go in, we could edit the definition. And we could go over here and say, hey, we want to pocket in maybe we want to say, hey, in this case, we'd really like to do about a 50% step over. We'll do a, kind of the old school 50% step down, and we'll leave 10,000 stock allowance. And it's not doing a profile pass around the outside because that's about all we've got is around 10 thousandths on this guy. We could go over and we could say, hey, we'd like to add, a different way of getting in the material. We could do a plunge, entry drill, ramp, entry hole, spiral, or ramp on a lead-in line. We could also give it a length and angle. So we could say, hey, give me a 1/2-inch lead-in and say OK to that. After that, we're in this particular case, we're using that same tool to finish. And so we'll go ahead and we'll add that contour pass. And as with any of the different packages, you could do it by Z level, you could do one cut, or you could continuously spiral down around that part as well. Let's go do our inside cuts. We'll use that same 1/2 inch tool. And in this particular case, let's go in and let's tell it we want to spiral down into the work. So we'll do a spiral and we'll leave that right where it's at. Maybe we'll change this pitch to a 50 thousandths, make it a little more shallow, and say okay to that. And then finally, let's go ahead and let's add our inside cut. Now, I don't need it to start at the hole center. We've already roughed that material out. So let's go in here and tell that operation that we do not want to start at the hole center. We don't want to end at the hole center. You can hit your F5 key on your keyboard, and it reruns that toolpath as well. At any point along the way, you could just say Shift Select, and you could just run toolpath for a bunch of different operations. And then finally, we get down to this area clearance. And so these are going to be our 3-axis operations. You can see we've got this whole thing selected. And so how are we going to contain it? If we look at what we've done so far, and SOLIDWORKS CAM Standard has the same simulation package that they all have at this level. And so let's go ahead and let's run to the next operation. Let's slow it down to just one move. And we'll slow this down a little bit so you can see it. So there's our facing pass. Then we're coming in and doing our outside roughing. Now I know that we're holding this guy with those mighty bites, and if we rough all the way down, we will have just wiped out our mighty bites. And so that's not something that we want to do. So at any point in time, we can go back over. We can look at that outside perimeter pocket. We can edit definition, and we can say, hey, instead of going all the way to the bottom, we just want to go to the bottom of the part, and it moves it. And we could add an offset value if we wanted to go, say, 10 thousandths past that. Then we know we're going to clean up real nice and easily when we face the other side of that part. So let's say OK to that, and we come back over here, and we'll rerun that toolpath, and so it automatically updates it to only go down to the bottom of that feature. So let's go back into our simulation, and let's let it just run real quickly to the end to see where we're at. So our mighty bite clamps are a low profile. We only need about 60 thousandths material, so we're going to have good clearance over top of them. So everything looks good. We might shorten up that tapped hole a little bit, but we can go in and we can say, do a comparison. Show me the difference between the CAD model and the cut part. And you look and you see, and anything light blue to dark blue is going to be stock remaining. So we can obviously see, we've got that stock remaining on the backside. Looks like we need to make our chamfer just a little bit bigger, and we'll do that in a moment. Our tapped holes are showing up in that yellow to red. You might ask, why is that? And the reason why that is that SOLIDWORKS models tapped holes at the tap drill size, and then CAMWorks displays tapped holes at the full thread diameter. So absolutely appropriate that you would see that. So I'm happy with that. But then we also see this area right here. We got all that stock left in there. So that's what we're going to address next. And that's a lot of what I wanted to share with you today, is that there's real value in the ability to do that 3-axis toolpath at no additional charge. So we asked the question, though, how are we going to contain it? There's rest machining in the higher level versions of CAMWorks, but it's not in this level of the version. But it's very easy for us to contain that toolpath. We're going to go in, we're going to go normal to that guy, and we are going to create a sketch on that face. So we're using our SOLIDWORKS tools. We'll go over and create a sketch, and we'll just right-click on this guy, and we'll say Select Tangency. And we'll convert all those edges. And then I know that I actually want to machine a little bit beyond this edge right here. So I'm going to go ahead and I'm going to pick this edge right here, and I'm going to do an offset of that edge. I'm using a 1/4 inch tool, so I can very easily go, I can go up to 200 thousandths without having this tool start to drop down or something like that. So, but in this case, what I may actually do is I may have my tool go on the center of that. So in that particular case, I wouldn't want to go any more than 125 thousandths. So I'm going to make this about 115 thousandths off of there, and we're just going to say OK to that. And then I also know then I'm going to want my tool to go out further into this pocket so I clear out these guys real nicely. So I'm going to, once again, I'll pick this edge right here. I'll do an offset of that edge. I'm going to offset it that same 115 thousandths. I'm going to reverse the direction, and I'll say OK to that. And let's go back to our view that we were running before. Let's go normal to this guy. And then we'll start doing some trimming in here. So let's grab these guys here. Let's pull them out to there. Grab that guy, pull it out to there. Let's draw a couple of lines. We know we want to get, clear out to this area here where our fillet ends. We'll just have it go, we can have it go straight out there. And over here, here's where our fillet ends there. And we'll just go out at an angle like that. And then let's get our trim tool and do some trimming. So we'll use our smart trim. Let's get rid of those guys. And I think we're good to go. And so SOLIDWORKS shows us that we've got a nice contained boundary. And so we'll say OK to that. And then at any point in time, we could name that sketch. Maybe I want to call it contain, so that I can more easily identify it with my 3-axis part. So let's go over here and let's right click. Let's add a contain. So we'll say new contain area. And then there's my sketch waiting for me right there. And then I've got some choices. First of all, I can offset that guy, which is beautiful and wonderful. I can tell that I want to go up to that edge, I want to go on that edge, or I want to go past that edge. So we'll say put the tool right on the curve, and we'll say OK to that. Let's go ahead and let's go into our operation. Let's see what we got set up for defaults. And we are doing a pocket in, which is what I want. I've got a 70 to 50% step over, which ought to be fine. We're not going to take a deep depth of cut. So we're saying 75,000 steps of cut. Yeah, I might drop that down to 50,000 steps of cut. And in this particular case, I might bump this up to leave about 15 thousandths. So let's hit our F5 key. We'll see what we get for toolpath, and we'll see if we're happy with what we've got. So that's what I'm going to get. I'm actually real happy with that. I like how it's starting outside the stock and clearing out some of that material in that little area there. And I don't need to do any rest machining, so I'm going to go ahead and I'm going to suppress that guy. And again, I can't actually do any rest machining. And then pattern project is going to be in the CamWorks version of the software. So instead, what we're going to do is we're going to right click and we're going to say insert a new 3-axis operation, and we're going to insert a Z-level cut. And so the system comes in and says, hey, what tool do you want to use? We're going to stick with that 1/4-inch ball. What feature do you want to put it in? Well, exactly right. We want to put it on that multi-surface feature, and we'll just use the defaults for our operation. So we'll say OK to that, and we'll just call it MS Finish. This is a feature that everything from CamWorks or SOLIDWORKS CAM Standard up through CamWorks Premium has, where we can name our operation on creation. And let's go over here. We'll do this Z-level cut, but we're going to add something else to it. We're going to make it a combination cycle, and we're going to say that with our Z-level cut, we're going to go from, let's say, 90 degrees down to, let's say, 30 degrees. And with our combination cut, we're going to go from 0, which will be horizontal, up to 45. And you'll notice we got a little bit of overlap, which is something that I like to do. We're going to step over about 20 thousandths for each of these cuts. And we'll make our deviation about 1/2 thousandths. And that's our quartile deviation. And then let's go in here and let's add that contain that we just created. So we'll say new contain area, grab our contain, let the tool go right on the curve, and we'll say OK to that. And then let's go ahead and generate that toolpath, see what we've got. And so it's going in there and clearing all that material out. Now we could work with our links and things like that in order to, change, you know, the number of retracts and that kind of thing. I'm going to go in here and I'm going to delete these pattern projects out of here. And we'll delete this other area clearance as well. We don't need that. And so finally, let's go in and let's take a look at what we've got so far. Let's run to the next tool. We'll let it go pretty fast through this guy. We've seen this already. So now we're into our 1/4 inch end mill. So let's slow this guy down a little bit just so you can see a little better what it's doing. So again, big point is that this is available in that standard version. And then finally, let's go in with our ball nose tool. We're going to speed this guy up because it's a lot of passes. And if we want it to go even faster, we can change our moves from updating the stock every 1 move to maybe updating the stock every 10 moves. And there's also settings for, you know, do you want to have a speed bias or a quality bias in your display? So you have a lot of flexibility in how fast you want this to go. So it's doing that Z-level rough around, and then it comes back and does that combination cut to finish it out. Now in this particular part, we actually want it to be kind of rough because we're actually clasping that rod that you saw, and then there's only a cable going through here. So we got a nice, you know, fillet cut there, so we're not rubbing that cable. We've got nice clearance for the cable coming through here, and we're going to leave it a little rough so it really grabs that that telescoping rod. So I'm really happy with this. I do recall that we didn't. So you know, we're in good shape on our material left. We didn't change our countersink hole diameter, so let's go back and address that, and then we should be good to go on this side. If we just click on that edge, we can see that's a 332 diameter, and so we've apparently got things set up just a little bit differently. And so we'll look at this countersink. Let's go in, edit the definition on that. Go over to our feature, and we can see that, well, it's not quite creating the right feature, so we've somehow changed our defaults along the way. We can override that at any point in time. Go in here and type in that 0.332 that we just measured, click set diameter, automatically changes that depth, and we should be good to go on that. And if we wanted to finish this guy up, we could go ahead and we could just go ahead and generate our facing on the back side. And let's, we've got this irregular pocket. We'll go into our parameters. I know I've got a default stored for that. Just finishing with a small tool. That's my default for that. And then I'm going to go ahead and I'm going to add another 2.5 axis feature. And I'm just going to add a boss. And if I pick this guy, then you know, it's going to go ahead and start adding in those edges, and it's creating its own join feature there. I could either take that join feature or I could pick that. And then for my end conditions, I'm going to go down to this point right here. And then for direction 2, I know that I've got an 062 fillet, so I'll just make that 062 5 high. And we'll say OK to that. Let's go ahead and generate both those guys. And let's make a few changes to our tools. Once again, let's take this face mill, let's drag it up to this 2-inch face mill, and we can generate the tool path for that guy. Let's go ahead and look and see what we have. We've got, that's going to be just great on that operation right there. So we're going to go ahead and cut that guy with the 5/32. And on this contour mill, what we really want to do is we really want to just hit that with our corner rounding end mill. And so let's drag that 1/2 inch finishing pass. That's going to be this guy right here to our corner rounding end mill. And here's our 062 corner rounding end mill right there. And let's go ahead and generate tool path for that guy. So if we run this through our whole simulation, so we'll tell it to run to the next setup. And let's go ahead and let's change our defaults to a little bit more of a speed bias. Say OK to that. and we'll have it update the stock every 25 moves. We really just want to fly through this first side. And so this is a real good time to ask any questions if anybody's got anything. Brian, Don, you guys want to add anything at this point?
No, I'm good. I just actually I had to step away for a minute.
Okay.
Really good.
All right. So here's our first side, completely done. We're happy. We've got our bigger countersink here. You know, everything's looking good. And so let's go ahead and then we'll move on to the next operation. So let's slow it back down. We'll update the stock every 1 move. And here we see we've got our face mill. Let that guy finish up. So we'd put this in our soft jaws to do this at this point. And we'll slow it down a little bit. Comes in, cuts our little groove there, and then comes in with our corner rounding end mill. And the corner rounding end mill automatically knows how deep to go. You know, it knows where that radius ends.
Hey, Jeff.
And automatically. Yep.
Jeff. I just was actually David Guza has a question online. He doesn't have a microphone. And,
oh yeah, sure. What is it?
Yeah, his question was that he's heard 2.5 axis and 3 axis, but what really is the difference, and is there something to be concerned with in the SOLIDWORKS CAD tool? He just wants to know what. Go ahead.
No, that's a great question. Yeah, I mean, so a 2.5 axis operation will still be generally run on a 3 axis mill. So you generally don't buy 2.5 axis mills. And when we talk about axes, we talk about axes of movement. So we've got our Cartesian coordinate system here. And so, you know, we already said our x-axis is the side-to-side movement of the machine. The y-axis is the front-to-back movement of the machine. And the z-axis is the up and down movement of the machine. But when we're doing a lot of these features, and then we can go ahead and get out of this for now, but, you know, we're just setting the z. Like when we did this corner radius, we came around, we set the z, and we could even back up on some of these guys. So you can see, you know, our z is at just one constant value as we're going through this guy. And so that's why we call it 2.5 axis, because we set the z, that's kind of our half axis, it's in a stable, you know, set plane, and then we're moving the axes around and we see, you know, x and y axis movement. So we've got to be moving those simultaneously, right, to create this feature. And so that's a 2.5 axis operation. But if we go back to looking at this guy, you know, that's a multi-surface feature, and there were times when we were actually moving x, y, and z simultaneously, and that's a 3-axis operation. Now, our SOLIDWORKS CAM Standard has light 3-axis capabilities. You know, if you want the full-blown, you know, we've got options for that. But it's so great that they include them at no additional charge in that package. Does that answer your questions, Dave?
He said yes. Thanks for the explanation.
Great. Thank you, Don. Thanks for being the interpreter.
Well, I made it back to, I just real quick, my little commercial here. The reason I had to leave, I'm working from home today, and I have a young heifer that I didn't think was bred that was bred. She laid down to have a calf out there, and the black buzzards started attacking her, and I went out to get the buzzards away so they wouldn't kill my calf, but my calf was stillborn. So in the time
my
you've been doing
goodness.
this, I've delivered a calf and got rid of the buzzards. I'm multitasking today. So.
Yeah, I would say you're the most productive guy on the thing so far. So,
right,
and then, you know, finally, no, great. I appreciate the story. So finally, what we'd want out of this, you know, if we're happy with what we've got so far, and I'm, you know, 99% happy with it. You know, the only thing I saw, I might go back and change that tap. I don't want to tap quite that deep, and we could set that up as a rule very easily. But since we don't have it set up, I might go and I'd override that feature. So instead of going a ½ inch deep, you know, I might go 400 thousandths deep on that guy. And my other option would be to drill a little deeper, which I might do as well. But if I'm happy otherwise, I can go ahead and I can say, you know, that I just want to post-process this code and we'll just call it test. We'll overwrite this test code right here, and we go ahead and we let it run. Converts all those moves we saw on the screen into G-code, and converts them correctly because Brian did the post. And so we can have a lot of confidence that we're going to get the same thing out at our machine that we got here in our simulation. And you can see these are actually the 3-axis codes flying by right here now. You can actually see it's moving X, Y, and Z. So if we scroll back up, there's full X, Y, and Z moves. That's our 3-axis code. And if we go in our options and say, hey, we want to open that code up in the CamWorks or SOLIDWORKS CAM NC editor, hit the check button, there's our code. You know, and Brian makes a beautiful post. You know, he's got all of this stuff very thoughtfully and in parentheses, so we could either read it on the machine control, set width so we can print it on our printer, and then the SOLIDWORKS CAM or CamWorks NC editor shows you, you know, what are the rapid moves, what are the feed moves, what are arcs, what are line moves, and what are like preparatory statements with the different colors. And then beyond that, we've even got a backplot capability in here, and we could go in and see all those tool paths backplotted that we created. We could even assign tools to those tool paths, and you could watch that guy run through. You know, in this case, we don't have it defined. Obviously, we're not facing with that tool, but you get the idea. And then finally, you could go and you could transmit that out to your machine if you were ready to do so. So that is a quick look at SOLIDWORKS CAM and the CAM Standard version capabilities. All those capabilities would be in the CAM Standard package. And then just as a final kind of a quick overview, what we're doing as we run them, we'd be running them with more of what's the SOLIDWORKS CAM Professional capabilities. And here, you know, Brian has done a great job of modeling up all these vices. You know, these are our Mighty Bite clamps, you know, holding that thing in place. And the great thing about, you know, being in the assembly environment is we can see, you know, where our clearances are. We can, you know, if I look at my Mighty Bite clamps, I can tell that I've got plenty of clearance down to the bottom of that part. And so when you go up to the CAM Professional, it gives you the ability to machine in the assembly environment. It's going to also add the volume mill. And so if we look at it, you know, we've got some face features through here. And then if we look over here, you know, here's that volume mill roughing. And we'll run it through our simulation so you get a little better idea of what that looks like. So we've added our vices as fixtures, our tables in there as a fixture. Yeah, we'll keep it kind of slow. And let's run to the next tool. So here's my facing. And I was actually using a volume mill facing operation on a couple of these guys as well, just again because that machine doesn't have a lot of horsepower. And then on these guys, you know, I just roughed away the area where it's actually going to be the finished part. And then here would be that volume mill tool path. So it's going in and it kind of scallops off that material. I'm running that at about, I believe, I don't know, 175, 200 inches a minute full depth, and running about 125 inches a minute to clear that material out right there. And then it's going over here, another volume mill tool path. And then we kind of mix and match. Volume mill wants to do a racetrack tool path. And so there's the racetrack, and then it'll come through and do the finish pass at the end. Here I'm just kind of treating that boss, and then I'm doing actually a spiral roughing right here. So it looks similar to the volume mill, but I'm just spiraling out, gradually taking, you know, more and more material as I go out, staying engaged all the time in that cut. And we'll go ahead and let's speed it up, and we'll let it run to the end of all the operations. Let's bump that up. We'll let it go to update the stock every 25 moves. And this is exactly what we're running on our machine today, and fully, you know, capable of doing this in anything through from CAM Professional, SOLIDWORKS CAM Professional, up through CamWorks. So Brian and Don, have I missed anything? Anything I need to share that I didn't share?
Actually, yeah, David had a question. I was kind of waiting for you to finish the simulation here, Jeff. His question was, he had heard something about selecting MFG view and then another view, and kind of wanted to know what the difference was. And I believe he's talking about the MFG view and how different versions of AFR. We can show him how to change that. But I do believe SolidWorks, you're using CamWorks, so you can change it. SolidWorks Cam does not. It does MFG view, which is kind of the newest way and the enhanced way of automatic feature recognition. Whereas the AFR method is the older previous method, legacy kind of method, and SolidWorks Cam does not do the old legacy method. It does the new and improved method only. So,
and that's why you're here,
I can have Jeff show you because he asked how to change it. So when he was done with the screen, so if he goes to CamWorks options, middle features, it'll say method there, MFG view. I believe that's what David's referring to. And it's a simple drop down there in CamWorks, but in the SolidWorks Cam, it stays MFG view. And for instance, if Jeff changes that to AFR, you'll see some of these options go away because it doesn't support it. So if he just temporarily changes it to AFR, some things will probably gray out and things will change. Yeah, so you see how some options went away because it's an older method, doesn't support everything. So, and whereas MFG view does. So,
thank you, Brian.
Thank you, Jeff.
I appreciate it.
Yeah, that was one of his questions. It was best to illustrate versus me trying to write a description.
Okay. Anybody else got any questions? All right.
I think that's all. I've answered some behind the scenes. He asked about post, Jeff, because he didn't see us in the list. I think you have just your narrow list. Expand the one. Go to Mill and expand that list because there's more that comes with it. I just think that we're filtered out with how you add it. But if it's not in the list, we can obviously get you a post, but he can show you the ones that does ship with it.
I always move my post.
CamWorks data. So, CamWorks data. Go to the posts. Go to CamWorks 2020 X64. Up one.
Shoot, that's yeah. There we go. I didn't realize I was on shop floor.
Yeah.
Okay. Yeah. So I don't ever run.
Post. Then go to Mill. Those are your posts, tutorial posts.
Oh, gotcha.
Here's the list of the different controllers that ship by default with it for Mill, David. And then if he goes back one, it'll show you the list for Lathe, which would be for CamWorks or SolidWorks Cam up at one, so it goes to the Professional. And those are the different controllers. So just to kind of show him the list.
And I do want to point out.
He asked if it's recorded, and this would be. So we'll have it uploaded on YouTube.
Yep. And I do want to point out that, one of the things that we feel strongly differentiates CAMs, from some of the others selling, SolidWorks CAM or CamWorks is the post, are the post processors. And, Brian puts every safeguard that he's aware of in those post processors. We actually had a situation, using some of the standard post logic with one of these assemblies, not this particular assembly, whereas it was moving from setup to setup where it wasn't actually going up to the right heights before it reached the next setup. And we ran into a situation with a tool where it actually knocked into the part. And so Brian then, jumped in and put his own safeguards in so that it's looking at the next heights of the next setup before it starts to move over there. And, he does similar things with making sure that the spindle's running before you start moving the machine. And so there's a lot of safeguards that we put in. And so even though we charge a little bit for our posts, we think in the long run that you're getting a much safer post and it's much less expensive than crashing a machine. So that's all for today. I appreciate you guys all coming, and you can reach out to us at cutmetalfast.com. You can email us with any questions, and there's an info@cutmetalfast.com there if you'd like more information on anything we've shared today.